First of all, let me introduce myself. I work as an IT manager for the School of Sciences and Engineering at American University in Cairo. As a matter of fact, if you work as an IT, that means you have transparency to everything within the domain you are working. I mean, any business is composed of physical resources, which is the equipments and the assets, material resources, which is any material or substance that can be introduced inside the business, human resources, the people who are working with the business, and financial resources, which gives a reason for the business to exist. I mean, if the business is losing money, it will close. If the business is making money, it will continue and be better if it is directed to the customer needs. The main is the information resources, because people will not pay for nothing. They will pay if they understand what you are doing. So the main issue is the mission statement, what you are doing exactly. What is your goal? Do you have a vision? Can you see around? Can you see people around? The people needs, the country needs, the world needs. And the mission statement that you sit to write and say, okay, I am in this business now. I work in nano business. I work in nano science. I work in nanotechnology. Or I'm just interested in nano and that's it. So if we want to make the nano effective in any country, it has to set objectives and to meet the requirements of that country. I mean, if you are running out of water, that means you have to find a solution for water desalination, for example. If you are running out of electricity or energy, that means you have to focus on energy source like photocells that can capture the sun ray and convert it to electricity. Or work in data storage, that means you have to develop media or storing cells and so on. So we have to set the goals and the performance requirements to make our operation successful. And what is the concept? I'm working as what? I wonder why not in Egypt now there is no thinking or idea of having an institute for nanotechnology. What about nano engineer? Who is working with nano? He has to be a chemist or a physicist or an engineer globally or scientist globally. And then I start introducing nano concepts and nanomaterials to him. We have one case in Egypt, Dr. Mona Bakr's company called Nanotech, Egypt Nanotech. We have also some other companies, maybe outside, that cooperate with us. Maybe some medicine is manufactured with nanotechnology, especially as food supplement. We have also some military application or مصانع حربية who are producing or تصنيع solar cells and so on. And we have nano emerging to our life. If you wonder, the AC, the alternating current, maybe within some years will vanish from our cities and it will be direct current, DC, and we will have, instead of these conventional lamps, we will have photodiodes. We will have photonic light instead of electronic light, which is a conventional filament that we are using. So everything must go within a general policy that gives the profile of the business. So we have to set where we are now and where we want to be and how to get there, so we understand the requirements. Otherwise there will be no potential. Whatever the enthusiasm we have, but there will be no potential because we don't understand our requirements. So it's nice to be fascinated by nanoscience and nanostructure, but it's bad if we don't put an orientation or directivity for our society, for our country, for the countries that we can cooperate with to set our objectives. I'd like to explore the main core of my presentation with this preceding lecture. So, if I go back to the mainstream of my lecture, I found the following gap. We are working with nanotechnology and nano size. If we want to benchmark any nano process, then we have to go back to quality. And the quality, the best quality ever now found within the market or the industrial market sticks to 3 qualifiers. How to improve the features, how to remove mistakes, and how to minimize the waste. How to improve features by giving new features to your process. How to remove mistakes, that means you have to limit your mistakes to 3 mistakes per million. And this is called the 6 Sigma convention. I mean, if you produce a million atoms arranged in nano form, then it is allowed to find 3 defective. 3 defective in shape or morphology, whatever. So if we are working in nano scale and we want to set the criteria for the accuracy and the precision, then we have to go to something higher than nano scale. If you have a meter, then you need a multimeter. If you have a multimeter, you need to calibrate, then you go to micrometer. If you have a micrometer, then you calibrate with nanometer. And then, so we need now picometer scale, picometer thinking, to think about benchmarking any nano process. So, to speculate, we need to understand 2 things within this. First of all, the structure, which gives how it looks. It's like how to arrange your room, how to arrange the nano, the particles within the nano is 100 nanometer, okay, to form a nano structure. And then you look at it. Okay, the scanning electron microscope or atomic force microscope or scanning tunneling microscope can do the job to look. But what about the characteristics and the behavior? How it behaves, how these atoms behave when it is arranged in nano form. If we go back to conventional chemistry equipments or chemical analytical equipments right now, we go for atomic absorption or atomic spectroscopy. You aspirate a sample. For example, let's say we have iron. We aspirate a sample of iron in an atomic absorption to see how many ppm. What about the iron in nanoform? Will it give the same characteristic in terms of absorption or emission? Of course not. So our equipments now, can it give the difference between same metal once in nano form or in non-nano form? We have to put this question because we need to find a way to develop or to get higher precision equipments to give a difference whether in atomic absorption or in spectroscopy, UV visible, or in chromatography or whatever. If you inject a material in chromatography with nanostructure and then you see the retention time, do you have the same characteristic as normal one? Of course it must differ because the absorption mechanism must be different, and that's it. So we investigate 2 things till now: how it looks and how it behaves. To detect this, we have to put a methodology, we have to put a culture, a concept. Then you have to think about the possible primary probes. I know there are people who are very much interested and very much focused in certain technology or certain criteria of research. But let's go back and have an upper view. What's going on and where we are, how we think. Then the possible primary probes for our thinking, we may use electrons if it is electronic. We may use photons if it is responding, if the process is responding to photonic exchange. We may use ions. We may use any form, so we can put these into concepts. We work as atomic if we are thinking of atom vibration or heat. We can think of light in all its bands, whether it's visible, ultraviolet, infrared, whatever. We can think of neutrons. If you remember last summer in CERN, there was a very rich experiment trying to detect where is the mass inside the nucleus of the atom. I suppose that you have an idea about this. And they called it the God particle or Higgs particle. So, where can you fit when you arrange atoms? Can it help physics? Can it help understanding new features? Then we have to think about what is the response of a nanomaterial or nanostructure or nanocomposite when it is exposed to sound. We might be having better speakers. We might be having better heat absorption. So we have to think about these 10 probes, and we have to give a monitor function. Monitor function, that means you have input and output and the transfer function, and here is the question of the sensor, the transducer. How do you convert energy into electric current to be able to measure it? So if you expose energy to a certain sensor, then you get some response. So how do you manipulate this response with signal conditioning to be able to detect it and to use the correct sampling rate to detect the change in the process? So we have to think about the energy, the temperature, the mass, the intensity, the time, the angle, and the phase. If we go back to analytical and imaging technique, first of all, we have to set what information is required about the sample. What do you want to understand with this sample? So you have to set a criterion. To use this criterion to be able to get the results. Again, what is the resolution needed? Your resolution in nanometers, in picometers, and I suppose we have problem in precision and accuracy. Many people maybe they don't have the correct definition that differentiates between accuracy and precision. I asked really this question to many people. Do you know what is the difference between accuracy and precision? And I always get, and most people, they get confused between the difference between the accuracy and precision. And I always say it in very quick words. If you ask me what time is it now, if I say it's about 12, then I have very low precision. And if it is plus minus 12 by a few seconds or a few minutes, that means my accuracy is not bad. But I don't have any precision. But if you ask me what is the time now, for example, and I say it's 3.0000000, then you find it's 2, not 3. That means I have very high precision, but very bad accuracy. So we have to think how accurate and what is the precision needed for our process. Again, let's go back to the information technology, which I am insisting to put it on the table, because all the researches we do must yield the two results. Where to put these results for others to benefit from. How to get the correct information or the correct data. Do I search, for example, globally? What are the research groups that we have in Egypt and in other countries? Maybe there is a research group, many research groups like Nano, like ResearchGate, like KTN, which are all research groups. But what about Egypt? This is a question. Because how can we interchange the information? How can we work together to formulate what we call it a cloud or a mesh or a grid of nano scientists who can cooperate and exchange information and benefit from each other? Otherwise, we will have discrete islands in each university, in each research center, and there is no effective connection between or among them. So we obtain the real information and we get our objective on the table, and then we start acquiring what we need actually to achieve our equipment, or the correct equipment or the correct data that we need. Another question comes is, you don't have to make everything real at first. What about the process of simulation? Can you simulate any process? Can you simulate the model of a nanostructure on the computer so you can put it in, I would call it, format that can apply to or can be applied to any mathematical model, computer driven like MATLAB or whatever simulation? I mean, you have an atom. What is the correct model for the atom if you put it in a computer? Then you have to think. Can I look at the structure or the morphology of the nanostructure in form of object-oriented analysis and design, for example? And we have, for example, three main functions in object orientation. The inheritance, which gives you the template of what you are doing. It's like the shape of the crystalline structure. And you have the abstraction, which is the amount of details you need to add to this form. And the polymorphism, which means, can you modify the function of this structure to do something else? For example, if it absorbs at a time, then it emits another time. Can you do this on the computer? If we are lacking the computer programming and the power to set models for our nanostructures, for our research, then we will be in great trouble. Why? Because we need the physical material to work with, which is not always available because of its price, and the environment needed to prepare it, and the equipment needed to make the analysis to understand how it behaves. There is a gap in Egypt because most of computer science studies at universities, they focus on something different. If you go, I have the AUC, for example, computer science students, they go to the internet, they go to Google, they simulate the bank model, the traffic model, and so on. But if you go to a computer science student and say, okay, I have this nanostructure, and I have this process of annealing, for example, or anything, and I need you to simulate this for me, I have no idea. If you go to people who are working with science, either in physics or in chemistry or whatever, and you introduce them to computers, then at first they will say, okay, they know PowerPoint, they know Excel, and they know some MATLAB, and that's it. So there is a gap. Yes.
You know, the director of the biotechnology program is a computer science.
Okay.
So there are many.
Which so how many programmers in Egypt? How many programming houses in Egypt? You can go to them and say, okay, I have this analytical process and I want to simulate it. Can you help me? So we don't produce films, we don't produce teaching aids, okay? Because we are lacking this in our culture. People for computer are interested in their computer models. In science, they do research, and if they go to computers, either they look outside for certain packages, or they stay, or they remain idle. So this is a gap that we need to fill. Again, testing the model to come up with new outcomes by software or virtually until we prove it in the lab, and then we compare the two results to check whether our model is good enough or it's lacking its dynamic attitude, it's a static model or dynamic model, it's event-driven or procedural or whatever. Again, the design steps actually starts like this. Because when you go for design, you said, okay, please, let me be in. As a matter of fact, they are complementing each other. Because if you deprive the feature of someone, the other one will compensate. It's like when you get someone who is blind or deaf or paralyzed, or no one, of course, can have all them. But they can work together to help each other. I don't know. If we go to the real design, then we have to put the situation. What is the situation now? I have some atoms. Okay, it's in liquid or it's in solid. I want to formulate something with nano now. I'm working on how big the structure, what is the environment, what is the temperature, what is the pressure, do I need vacuum, do I have to charge the sample, or maybe it's negatively charged or positively charged. So the environment, so you have to put some analysis for the situation, then you write a brief. Then you carry out the research, work the possible solutions, and then select the preferred solution, then prepare the working and drawing and the plan ahead, construct a prototype, and write a report. You have to be structured. You have to work in layers. Then we go to something very important. How to decide? You have two approaches. Either you have an idea about what's going on and you have ready-made solutions, that means you think in engineering form. Or you have no idea about what's going on and you think in scientific form. And if you think in scientific form, then you need to define the problem, collect the data, develop a hypothesis, test the hypothesis, and then analyze the results and draw the conclusion with a bit of statistics, of course, because you have to understand the shape of the population, the mean, the tendency, and go further with from descriptive statistics to inferential statistics to get the significance of a certain variable, the impact of that variable on what you are doing, and then come up with something effective. The other approach is using concurrent technology or concurrent solutions. Go and buy it. Go to a certain place to measure because they have the equipment. So we are dealing with ready-made equipments. We define the problem, collect the data and analyze it, search for solutions, evaluate the alternatives which is currently available. That means you need assistance from somebody who has previous experience. So if you have a problem in Nano now, where do you go? Where do you go? Whom you ask? How can you guarantee that you are asking the right one? Do you know each other? Do you know how many people working in Egypt now on nanotechnology? Is there any big belt or a circle that gathers them or combines them to form a society? So if you submit a question For example, if you have a question in religion مثلا, you can go to Al-Azhar and say, okay, I want to ask about this. They will say, okay, it's 1, 2, 3, 4. What about Nano? Whom you ask? Your professor only? What about others? What they are doing? Or everybody is working and putting pieces together and hiding and say, okay, this is my work. I will not let somebody else use it. This is again a big question. Again,
it's a goal of Naqaء. Goal of Naqaء.
Okay, this is one of the great issues of this network, Naqaء network, which means we are trying to connect people who are interested, who are really working, and put them in one package so they can cooperate with the synergy, of course. Okay, the impact of IT actually, that means you cannot work now in scientific research without experience with information technology, because the image processing for the data you acquired through images needs someone who has a bit of idea about data mining. And to arrange the information in a database form so you can store the data, manipulate it and present it, and convert it to persuasion or knowledge, that means you need a bit of IT culture. And that's it. And again, I would suggest something called the nano informatics. I know there is bioinformatics.
There is
now.
nano informatics, but
Yes.
I don't have any idea how to.
To implement, or it's, well, it's, I would say it's an innovation that I imagine.
Really?
Yes. I like to put it that way. We need to gather information about the sample, its morphology, micro or nano structure, architecture, its crystal structure, detailed atomic arrangement, and the chemical phases contained within the microstructure, its chemistry, the elements included, and possibly molecular grouping or molecular engineering, whatever, and the electronic structure, which is the nature of bonding between atoms. And again, we have to put some data about our nanomaterial in form of database, so we can manipulate this data either by our processes or by somebody else, or we exchange this data. So we describe the nanomaterial in this form, size, shape, morphology, form, solid, liquid, type, metallic, semiconductor, magnetic, hybrid, composites, properties, physical, chemical, electronic, photonic, electrical, magnetic, thermal, the elements, substances, handling and preparation, and the detection devices used with this element, and application category that this sample is used in. It's used in biology, it's used in medicine as a catalyst, or for energy, electronics, whatever.
There is something called the computational nanotechnology.
Okay, this is one of, but I'm talking about a system, an information system. It's like a guide. For example, if you search for a company in Egypt, there is so-called the Cairo Guide, دليل القاهرة, دليل الشركات. So we need to build, not encyclopedia, a database for the nano researches and projects in Egypt, so we have a bit of idea who is doing what, where, when, and why. And can we benefit from this? Can we cooperate? Or everybody is just digging his own hole and nobody knows about it unless you are friends or you are working together? This is the main question. And this is my main target by being in IT. I would say, the backbone. It's like the Facebook. And we have some forums, but very weak. It's not productive forums. It's not official. It's not official. Again, I actually, I took the electron microscopy as an example of machinery, engineering used to help people who are working in nano field. Why electron microscopy? Because we have many developed methodologies to detect. For example, photography. What is photography? It's like you apply light to someone and then you get the reflection and then you receive it on a sensitive film. If you go for X-raying, then you are passing an X-ray through the body. If there is an absorption, it will be an area differs from darker or brighter. So it's the same concept. We have 1, 2, 3, 4, 5. First of all, the scanning electron microscope, transmission electron microscope, atomic force electron microscope or atomic force microscope, scanning tunneling microscope, and scanning probe microscope. Which one to use in what sample? This is the key. And the resolution, if you work in few nanometers or in angstrom, that's it. What is the type of the sample? If it is metallic or ceramic, that's it. And to detect the functionality, you just read the title. I would say scanning. What does it mean, scanning? That means you have a range of frequencies or a range, physical range. I mean, you start by point and you end by another point. But what is the step, the increment? You increment in atomic scale. I mean, you increment in angstrom, or you increment in what? In nanos. This is the scanning. And if you say electron microscope, that means you will use electrons to hit the sample. If there is a secondary emission, that means these electrons, the instant electrons, are exciting some electrons from the surface and then captured. How can I capture electrons? Then I need an electron capture detector or a photodiode, for example. Transmission electron microscopy, that means I need to transmit electrons through the sample. It looks like the X-ray. Atomic force microscopy, that means if you are, I mean, you have seen in movies or old enough, the discs, the old discs that use a needle or stylus that gets into the engraves within the track, and then the vibration of the needle is converted to an audio amplifier and then you listen. So that means the atomic force microscope, that means there is a probe touching effectively the sample surface, and by ups and downs then you detect its surface. And in a scanning tunneling microscope, that means you can get some potential. You don't have to touch the sample, you get closer enough in fewer angstroms and you apply some electric field. And there is a current passing from the out surface electrons to the probe, and if you stabilize this current, then you have a bit of idea through a servo motor about the height it works to stabilize the current, which is equivalent to the surface of the specimen or the sample. And finally, scanning probe microscopy, and again, how fine the probe. Now the finest probe is the nanotube, because it's flexible, okay? It does not harm the sample, it can go through its valleys, and it's the needle now. And let's get to some ideology. If we look at this system, scanning tunneling microscope, then you find a needle, okay, and this is the specimen, and again you watch the vertical motion and the sweep motion, and you have a current passing to an amplifier, and this vibration is transmitted to calibrate the height through a piezoelectric scanner. Again, if you look at a system like this, think about what is the precision of the stepper motor, the increment, the delta, how accurate your steps, okay, and how to develop this system. And at the final end, then you will watch how the surface looks. The scanning tunneling microscope actually invented in early 80s, okay? That means we are now 20 years, 23, 30 years, okay? What about engineers? What about engineers? Who is studying in Faculty of Engineering the theory of operation of the scanning tunneling microscope or the electron microscope? Does not exist. Which means again that colleges or Faculty of Engineering at Cairo University or Ain Shams University or Banha or whatever, they are not supporting what's going on. They work in their problems. Maybe you find people working on mobile phones or satellites and so on, but again, we need to support the nanotechnology by culture from upper layer. I mean from the professors who must introduce these technologies to students so they can support the operation or in mind.
Policy maker also.
It's a policy, it's a main problem. You cannot drive a car within your homeland. You drive it in a public street, which means there must be a law. There must be a traffic law. And again, it's from upper layer, not from bottom up. Yani, can you imagine to be an entrepreneur or you create your own nano project alone? How much you put to buy a microscope like this? And after you put all this, what will you gain? Support some research, and then what about the nano products? Where is the revenue? How can you get money? How can you sell products? Nano products now are everywhere. What about us? Scanning tunneling microscope, I don't want to get into the very fine details because it's very common. You can open the Facebook or open the Google search, Wikipedia, and read it in details. And I have the presentation, of course, if you can get a copy. But let's get to something higher with the concept, for example. And this is, again, a very controversial issue. If you look at this, you have a sample surface, and then you have some vibrating cantilever, and then you have a probe, and this probe is sweeping with the surface. And then you have a laser gun that sends the beam and picks the reflection on a photodiode detector, and then you have a feedback electronics. Again, can we find electronics engineering students working in a project to mimic or simulate a device like this? Why not? Again, it's a culture. There is a very large gap between engineering and science and application. So we need someone to do this magic binding, to find new generation who are working or who is working, new generation students who likes to work or who like to work with advanced technologies like detection technology. Okay. As a matter of fact, I'm just skimming. This is one of the scanning electron microscope. Again, you have a beam directed to a specimen, and then you have electron detectors, okay, and amplifier scanning, and then you get the image, and of course, if I were to get into a system like this in a 30-minute lecture, I would be crazy guy. Either I fool myself or I fool the people, because it carries lots of details and lots of theories, and it has to be in detail. But the mainstream is we use electrons or we use light. We use laser, we use vibration, we touch the sample or we don't touch, or we go very close in the vicinity or affinity of the sample. That's it. This is the main technique. As a matter of fact, I want to go back to something I end up my presentation with, because I really like it. The similarity of physics is a sign of universe creator similarity. The universe creator طبعا Allah سبحانه وتعالى الواحد الأحد, which means we don't find something different in nanotechnology. I always objects in a row. We know all that matrix, if we put numbers in very discrete form, it has characteristic, and if you put it in a matrix form, you can solve a problem. You can solve many equations simultaneously. And you get the inverse of the matrix and do transpose and do lots of operations. It's the same with material. So what applies to numbers applies to material, because ما ترى في خلق الرحمن من تفاوت. And in this, فارجع البصر هل ترى من فطور ثم ارجع البصر كرتين, which means you look 3 times. One to have a look, and then another looks, which means plus or minus. First one is just to detect what's going on for brain cognition, and the second and the third, because وهديناهم النجدين, that means you go bad and you go good, and then you find yourself in the middle at the correct. طبعا من يهدي الله فهو المهتدي, which means I don't believe that there is no innovation. We are guided by Allah, by God, who gives us, who inspires us, who gives us the ideas to detect and to understand. But if you claim as a human that you are the unique creature on the world who only knows and who can invent, I'm sure you are in a very great trouble. فإن سبحان الله واتقوا الله يعلمكم الله ولا يحيطون بشيء من علمه إلا بما شاء.
كل تعلمون الله.
That's all.
كل واحد فيكم
Thank you, Dr. Tarek.
Yes, I'm sorry. I'm very interested in your concept of nano informatics.
Yes.
It's a really great initiative. But
Yes.
I don't know, do you have an action plan? Because this is just an idea, and it's a very good idea for Egyptian researchers,
Okay.
as a nationwide. Do you have an action plan? Will be very, very useful as a network for all these nano researchers.
As a matter of fact, we have to do some surveying and to get a bit of to assess the situation. It's like the 5W, who is doing what, where, when, and why, and then put it in a database format to classify nano materials, nano objects, people working in nano, industries that benefit from nano, and then put all together, trying to put an, as a matter of fact, I do apologize because I don't have an action plan.
And you don't
It's just an initiative, and if I find someone who can help me to settle it, I would be grateful, because we need to apply same concepts that we use it in bioinformatics in nano. So we can come up with ideology or a new ideology that we don't start from scratch. We don't invent from scratch. We use templates to fill and then create the cloud of the nano.
So could you apply this as a kind of project, maybe you can get a fund from the government or STDF or
It would be a great idea. I would love if we can cooperate.
sure.
Okay, thank you.
Thank you, Chef. I will thank his audience.